So we are going to end with just a couple of algebraic definitions for the absolute value. Now these will come up later, so I'm going to just expose you to them and we are going to go in a little bit more detail as they come up later in the course. But our first algebraic definition is that we can think of the absolute value as the positive square root of the square. So we can think of this as, for all real numbers x, the absolute value of x is the positive square root of that number x squared. Now we can show this and substitute in for a few different numbers. Now let's just, for example, say x is -3. If we take this definition, we are saying that the absolute value of -3 is going to be the square root of -3 all squared. Now, we know that the absolute value of -3, we did this before, so we know we're going to expect to get +3 out, but let's just verify this with the right-hand side. If I take -3 all squared, that gives us 9, and the positive square root of 9 gives us 3. So we can say, therefore, the absolute value of 3 equals to 3. We expected to get this because we know from the previous video what we're going to expect from this. But this rule does hold. So when we substitute in x being -3, substitute it into and think of this as being the positive square root of the square, we get this relationship that comes up. Now, the next thing we're going to talk about is kind of final definition for the absolute value, and it's going to be quite important when it comes to actually graphing the absolute value function, is this idea of thinking of the absolute value for different cases. So if x is a negative number, we can say the absolute value of x is -x, which is the opposite of this positive case x. So we can generally say that for any real number x, the absolute value of x equals to x when this is greater than or equal to 0, or it's going to equal -x for x being less than 0. So we basically cover all of our bases here with our inequality. This is basically talking about across the entire domain. So it's going to equal x for x being greater than or equal to 0, or -x for x being less than 0. Now, just a final little use of this second relationship, this second definition, we're going to look at thinking of a table of values where we have a bunch of different values of x here, and we are going to substitute these into a rule to figure out how the absolute value of x will behave. And this is going to introduce our absolute value function, which we'll be looking at more in detail later in this series. But filling out this table of values, if we take the absolute value of -2, we are going to get +2 out. If we take the absolute value of -1, we get 1 out. Absolute value of 0 gives us 0, and the absolute value of 1 and 2 give us 1 and 2 respectively. So if we think of this on a Cartesian plane, because with all mathematical relationships, graphing it gives us an idea of how the relationship behaves. So we are going to graph the function y equals the absolute value of x. So our y on our Cartesian plane is just going to be this output here, this absolute value of x. So I'm going to plot all these points in. I have 0, 0, 1, 1, 2, 2, and -1, +1, -2, +2. And when I get this, you will notice that I get something that looks like this. I get basically two straight lines, and this represents my relationship. So this is what our most basic absolute value function is going to look like by substituting into a table of values like we've done with many functions previously and looking at how this behaves. And if we just look at this quickly, the output, so the y value, the thing we get out of our function, it's always in the positive region of the Cartesian plane for y. So we can say, as we expected with the rule that we came up with, our absolute value of x is always positive. And this graph kind of confirms that in its most basic form, y equals the absolute value of x. Now, there are going to be times because we can shift this graph like we've done with our other functions, left, right, up, and down. So you'll see how this behaves as we get to more complex graphs. But this introduces our absolute value function in the most basic way. But this brings us to the end of the video. Thank you so much for watching, and I'll see you next time.